All right. Well, hello, everyone. My name is Luis Figueroa, and I'm one of your chapter leaders. I want to welcome you to the 2016 kickoff meeting. We are excited about the speakers lineup we're putting together this year, and we're looking forward to our upcoming sessions. For those new to our virtual chapter, our meetings are focused on all aspects of the data science lifecycle, from data acquisition and transformations to statistical analysis and data representation. So we cover both academic and technology-specific topics. If you are in the data science journey and would like to share your experience and any related topics, please contact us at datascience@sqlpass.org. We would love to have you speak at one of our meetings. So before I introduce our speaker today, I would like to share with you some information about past and some upcoming events. So in the current slide, you can see many of other past virtual chapters. If you see any other chapters you'd like to join, please head out to www.sqlpass.org/VC. There you can join the chapter and start receiving updates about upcoming events. Also, in this slide, you can see some of the upcoming virtual chapter meetings for the month of February. As you can see, there's a great variety of topics. Please take a look, and please, we would love to have you join any of the other virtual chapters as well. Now, PASS is known not only for the virtual chapters, but for organizing several local SQL Server conferences known as SQL Saturday at many cities around the world. Here's a list of the upcoming SQL Saturday events. Now, PASS would not exist without its global network of passionate, dedicated, and hardworking volunteers. So volunteering at PASS is rewarding both personally and professionally speaking. So if you'd like to join our team and volunteer, please go to volunteer.sqlpass.org. And lastly, we would like you to stay involved. So to learn more about free learning opportunities and events near you, follow us online at any of the following websites. Today's presentation is Window Functions for Data Science by our very own Mark Tabladillo. Mark is a specialist in the data science and analytics. He is a Microsoft MVP and SaaS expert. Mark provides training and consulting for companies in the US and around the world, and he also teaches part-time with the University of Phoenix. He is also chapter leader for the past Data Science Virtual Chapter, and he regularly tweets at marktab.net and blogs at http://marktab.net. So today's session will be recorded and will be posted to our YouTube channel later this week. We will send an email update with the URL to SlideShare where Mark will be posting our slides. So without further ado, I'll pass the presenting role to Mark.
So thanks everyone for attending. This presentation is called Window Functions for Data Science. My name is Mark Tabladillo, and as Luis said, I'm based here in Atlanta, Georgia. Welcome to this presentation. We'll talk today about window functions. These are powerful analytic functions built into SQL Server. These were introduced in SQL Server 2005, the core window functions, and 2012 added some time and statistical percentage window functions. They allow for advanced variable creation and are of direct benefit to people creating features for data science. And this talk, I'm going to also have two specific books that I will recommend at the end of the presentation for further reading and direct application. And by the way, this topic is required for certification. So if you are pursuing certification, you will need to know about the window functions. So what is a window? A window is a set of rows defined by the over clause. So on the right side here, there's an order by clause. There's 3 sets, and we see 1 window. So there's 1 window on the right side. And if I go to the next part here, I have a partition by. Now partition is going to make 3 windows. So that's what is going to happen. So there's going to be 3 sets, and they're going to be 3 distinct groups. So that's what the windows are about. There are some functions that are available, and we'll talk about the different functions as we go into this presentation. The first group is the ranking functions, which is the row number, rank, dense rank, and entile. The aggregate functions have a lot of statistical functions that specifically would be of interest to someone doing data science. And certainly the analytic functions are also very powerful, included a number of functions that are important for data science feature creation. Important statement I have on the page here is that the group by statement is not required. So let's go into a demo for the ranking portion of our talk. One thing I want to let you know, and I'll wait for the screen to come up, is that I'm using Microsoft Azure today. This morning I provisioned a SQL Server VM. It's just a virtual machine that has SQL Server 2016 already running in it. And I just chose that image, and then I provisioned the server, and so this is how it looks. It allows me to connect through remote desktop connection, which is how I'm connecting today. And in terms of my payment, I'm not specifically paying for this because I have an MSDN license, which has a certain amount of credits per month available for me to use. And it's like use it or lose it, so you don't get a check at the end of the month for the remaining portion. But it's used against that credit that I already have. So when I open up the session, so right now we're inside the remote desktop session here, and you'll notice in the bottom screen, it's just the screensaver. It says Windows Server 2012 R2. I'm going to show you a little bit about this PC as we're starting here. If I go to System here and I just see what kind of system did I get, well, first of all, I'm going to show you what system I ordered. Then we'll talk about what system I got. When I had the ordering process, at the very beginning, it did ask me to choose a size for the server, and then it gave me an estimated cost for how much that would be per month. Virtual machines are some of the most expensive options to use, so you got to be careful to use them only when you need them and shut them down when you're not using them. So I will be shutting them down because you see the cost is in the hundreds of dollars per month. I only have $150 of credit per month. But when I chose the standard machine, it didn't show me exactly what CPU I was getting. So inside the machine, it now shows me what CPU I did get. I have a 14 gigabyte RAM, and we have an idea of how large that is here. And then if I go to the task manager, it'll open the basic screen, go to more details, go to performance, and then it'll show me again here that I have an Intel Xeon CPU E5-2660. Now, I'm always a novice on just knowing how big these things are, so I will go to a website such as the one I have here, cpubenchmark.net. Has a lot of statistics here on different CPUs and exactly how fast they run. And so this line here shows me that I think this particular server was first tracked in the April 2012 range, and then has different benchmarks here that I can tell how fast CPUs are compared to one another. So it gives me some comparative numbers. That's something that you can use if you're provisioning virtual machines. For our particular demo today, I'm using the AdventureWorks sample databases. These are available through codeplex.com. And as you notice on the screen, this particular one just got updated for SQL Server 2016 CTP3. Now we're recording today, so I'm sure that by the time some people see this recording, SQL Server 2016 will have been released, or maybe it'll be on a different version. But you can see that in the past, I can go back and get the AdventureWorks database for 2008, 12, or 14, and that's all available for free from the Codeplex website. Now I'm going to go into SQL Server. So right now I'm going to open Management Studio, and of course today we're running 2016 CTP3. I have some databases on the left, and you'll notice that I really only have one database in here, which is the AdventureWorks database in the upper left corner. Now I'm going to open a file. I already have all my scripts listed in a particular file here, this project, and of course they're all opening now. I made the print a little bigger so that they would be able to be seen better. But I have these 13 files, and let's just start going through them. All right, so the first thing I'm going to do is I'm going to do this first script, and I'm just going to go run the whole thing, and then we'll talk about it. So all I did here was we have two columns here. These are doing select statements from the dim product table. I like the product table, and I think I'm using it today in most of the examples. It's got about 600 rows in it, and it's a dimension. It's not a fact table because we're just doing a sample. And I'm going to tell you too, for actual application, when you're thinking of using the window functions, what I would recommend doing is getting a sample of your data and running through some of these types of demos to make sure that you're getting what you're getting, what you expect to get, instead of just doing it against millions of rows and then having to wait. So go ahead and do a sample similar to what I'm doing here. So right now what this did is it did color, and then it does row number over order by color as color row number. So if you see down here, this column is color, so this color column will be sorted. And if I just go up and down the screen, the first one here is black, and then some of the other colors here, blue, multi, NA, which means missing, so that also gets included, red, silver, yellow. Okay, so yellow is the last one. So it's going to order first by color, and then it's going to give it a number. Now, all the blacks are going to be sorted together. So do I know exactly which black is going to be numbered 1? I don't. But I do get a general order that all the black colors will be ordered first by row number. And then after we're done with black, then it's going to go to the next color, which is going to be blue. So here's the end of the black. The last black number is 133. The next blue number is 134. And then it starts numbering from there. And that's how the numbers go. So let's go to the next query. This is going to do a row number over order by product alternate key as product alternate key number. And that's the product alternate key here is on the left side. And these keys, these specific keys are, let me see if I can try to do something. No, it's not going to work on this. All right, so these specific keys are more unique than the colors were. So like the first key here gets numbered 1, and then 2, and then 3, 4, 5, 6, 7, 8, and then it orders it all the way to the end. Now, if 2 of the keys happen to be the same, and I found one here where they are the same, it's just going to pick one of them, and it's going to number it, and it's going to pick another one, number it, pick another one, it'll number it. But they'll all be in order overall and all the way to the bottom, and that's how you get the row numbers. And row number here for the last one, English product name description. So, and then this was, notice too that I'm doing order by descending. So I'm going to do in descending order to show you that it will do it in reverse order. And here's the name of the products. First one here, women's tights, and then in that order, it's going to be in alphabetical order. And then on the second column, it'll have the row number. And then it gets numbered again from the beginning all the way to the end. And again, if some of the names are the same, it'll just pick one and then just assign a number. That's what it's doing. Okay, row number. Now you also can do multiple keys. And so this one here is color and product alternate key together. And that'll allow you to sort it by one, sort it by the other, and then assign a number. And if you want it to be exactly unique, then you just would put something in this order sort that is one of the unique fields. So like the unique key could be as part of your field, and then you'll get unique results with the row number. So that's row number. Now let's do rank. I'm going to execute this command. Rank is going to do what it says, and that's it's going to rank it together. So here's black, and they're all ranked 1. They're all number 1 because black, it doesn't matter. They're all part of the same group, and the group is black, and black's alphabetically first and number 1. So they're going to all be 1, and then let's go down and see what happens when you get to blue. When you get to blue, the next rank is going to be 134, and the reason is because there were a total of 133 that were ranked number 1, and then it's going to go to 134, and that's how rank works. So rank's going to go to the next number, so it's going to jump to 134, and by the end of the group here, so here's some silvers that are all ranked 498, and then the next silver slash black is 550, and those are all tied because they are all the same, and then it goes to the end. Okay, the next one here, the next query, rank over order by product alternate key. So this is the same key I used previously. Now, since many of these are already unique, you're going to see 1, 2, 3, 4, 5, 6, 7, 8, which is what it shows here on the screen. Sometimes product alternate key is going to be the same. So I just found one here, BKM68B46. So those two are the same, so they both get rank 32, and then the ones after that get rank 34. So that's how that ranking works. Going to the next query, it's going to be rank over order by English product name descending. So these are the products. Again, the products in this case have very unique type names. So you're going to see 1, 2, 3, 4, 5, 6, 7, 8. And then if the names happen to be the same, then they will get the same number. That's how that works. If they happen to be the same, like here's one here that had the same number, 78. And then also you can do this by a combination of keys. And you also can do descending in here. So these will be done descending. Okay, so that's rank. Dense rank is the next type of query. I'm going to move this, actually I'm going to move this window up because I think you can see that a little bit easier. So here's dense rank and rank put together on the same query. So black, okay, color dense rank and dense rank are the same. They're all ranked number 1, but let's go to the end of the first group here and see what happens when you get to blue. So what happens is the dense rank will go from 1 to 2, and the color rank, the regular rank, will be 1, and then it goes to 134. So what's the difference? So dense rank, what it's doing is it's like numbering the groups. That's the way I like to think about it. So black is the first group, so it gets number 1. Blue is the second group, so it gets number 2. And then by the time I get to the bottom, I see 10. So what that tells me is that there are 10 distinct groups of color on this ranking. Meanwhile, color rank here on the right represents the ordering, and of course it's not the number of rows because the total number of rows is 606. 561 was the last place it got to a tie, and then they all tied at 561. So it's going to be less than the 606. All right, next query. Similar thing, I'm going to do dense rank over the product alternate key. So we have our product alternate key, and you know these are already very similar. Okay, so going 1, 2, 3, 4, 5, 6, 7, 8. You're only going to see a difference here when it starts changing. So these are 26, 27, 28, 28. And then, because these two tied at 28, there will be a 29 in the dense rank, and there will be a 30. So it's going to hit all the integers on dense rank. Meanwhile, rank will not necessarily hit all the integers, and so this will be 26, 27, 28, 30, 32. So it's skipping numbers, and that's how the difference between dense rank and rank. Okay, same thing for the product description. So again, a lot of these are very similar, and if I go down, I can find places on the left where, because the rank is skipping integers, it's going to have a higher number, then the dense rank will have a lower number because it must hit every integer. Dense rank will hit every integer. And then you can also do it by multiple keys. I only have 2 here. You can add additional ones yourself. And that's the color and the product alternate key here, and I put 2 together. All right, Entile. Entile really stands for percentile, and what it's going to do is it's going to make groups. So Entile 7 is going to make 7 groups ordered by color. So right now it's going to take the colors here. They start again with black, and they go all the way down to yellow. Whoops, I grabbed the wrong thing. I go back here. So it's going to start with black. And if you can imagine, what's going to do, all the rows will be in order here from black to the end. And oh, by the way, this ordering is only affecting the calculation of this window function. if I happen to have several ones in here, it's not going to reorder the output necessarily by one or the other. So you don't know how the output necessarily is going to be sorted. All right. If you want to force the sorting, you have to do an order by statement at the end. Okay. This one happens to be simple, and in this case, the engine's just returning the order in this order because it had to sort it in this order for this particular function. So that's how the sorting works. So it's going to now take those rows and then divide them into 7 groups. The thing, though, is when it divides it in 7 groups, if I go up to the beginning of group 6 here, the end of group 5, let's see how this breaks. Oh, you know what? It actually broke right on the color. That's interesting. So let's go to 4 to 5. Let's just see this. That was just coincidence. But group 4 here is going to be the end of the NA, and then also there's some NAs that are going to be in group 5. Now, for any particular row, like 349, do you know if it's going to end up in group 4 or 5? You don't know, but it's going to put them in order, by color, and then it'll put the end tiles, so it'll put one of them in group 4, and then this one's going to be in group 5, because color is not a unique key. It's not a unique key, so it will. There is an answer, but it's as we'll see later, non-deterministic. Okay, the next one here, end tile over order by product alternate key, and that's of course the product alternate keys in the beginning here, and then it's going to take the results, sort them in that order, and then it's going to make 7 groups, and those 7 groups are going to be in order of the product alternate key. Okay, next one here is going to be end tile over the English product name, and it's going to take those product names, and then it's going to make 7 groups. And then end tile over order by color product alternate key, and that's going to take it and sort it by those 2 fields, and then give me 7 groups. And they're going to be roughly the same. So that's what's going to be done on that field. All right, let's go to 5. All right, now let's do some partition by. So this is now where it starts to get tricky. Now that we understand order by, now let's do partition by. And partition by is going to be something we'll see how it does. So this is going to row number, so we're going to use 2 columns here. We're going to use status and color, and it's going to partition by status, order by color, and give me the row number. So status is first, and then color, and then the row number, black, 1, 2, 3, 4, 5, 6, 7, 8. And those are all nulls, and I picked this one because this technology does work with nulls. So nulls are going to have a place in your window functions, and don't think that null is going to throw it off, because it's not. Null will be used. And then what happens here is at the end of the null, you see this is the last row, then it's going to get to 200, and then it's going to start over at 1. It's going to start over because the status number changed. So the partition is going to determine a whole new group. Every partition is going to get its own numbering, and that's why it goes to 200 here for the nulls, and then it's going to start over at 1. And how do we know to order it in this current? We're ordering it by color. So the order's by color, and that's what's going to start with black, and then it's going to go all the way to yellow again, all the way to the bottom. That's the ordering. Okay, next one here. This one we're going to order it by color and product alternate key. So the first numbering is going to start with black. All the black products are going to be together. And then at the end of the black, the last one here is 133. Then it's going to start over because this is a new partition. This row is blue, so it's going to start over at 1, 2, 3, 4. And it's going to be in the order of product alternate key. So the product alternate key is going to determine the order. That's what happens. By the way, this is getting recorded, so if you feel like you need to study this, you'll be able to play the recording again and convince yourself of what I'm saying. All right, so the row number over partition by color, order by English product name. So this time I'm using color and English product name. And so again, black's first. It's going to start 1, 2, 3, 4. And once I get to blue, it's going to start over again with the numbering, whatever the number is, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it's going to go higher numbers from there. And then this last one here, it's going to be partitioned by status. That's going to be the numbering group. And then it's going to be ordered by color and product alternate key. And you could reproduce this command and you can run it for yourself. But that's the numbers that are there. 6, rank. So what does rank do? This one's going to be rank over partition by status, order by color. So that's what I'm going to show here in this first query. Status here is null. Color is black. Color rank is 1. That's going to be 1, which means inside the nulls it's going to start at 1. Then it's going to go to 85, and that means that 84 were in the black color, and then the blue ones will be 85, 85. Then it's going to go to gray, 87. And similar to before, the only difference between the previous one is you might expect with the partition, it's going to start over on the ranking once it gets to a new status. So once it gets to the end of the null here status, then it's going to go to current status, and then it's going to start over 1, and then it's going to go higher from there. Rank over partition by color, order by product alternate key. So these ranks here are going to be done 1, 2, 3, 4, and again, it's going to change when the color, it's going to restart when the color changes. It's changing actually when there's a new product alternate key. It changes when there's a new product alternate key, but it will restart, meaning starting at 1, when the partition is a new color. And that's going to be how the partitions will help make a new listing. Similar thing here, if you do rank over partition by color, order by English product name, descending, it's going to start 1, 2, 3, 4 for each color, and then the order is going to be by the English product name. And then similarly, you can do 2 keys as your order by with the same key for status. So status, again, it's going to, for each status, it's going to start it's going to start over again, and then will be in the order by whatever's behind the order key. 7, dense rank. So we've seen dense rank before, and of course the difference here is going to be that the dense rank will start over by a new status. So a new status is going to start the dense rank over again. Let me go to the right. So here's status, and here's colored dense rank, and again, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to go higher, higher, higher. But right when null changes to current, right there, null changes to current, and then dense rank is going to start over again at 1. And as you remember, dense rank will hit all the integers, while rank may skip integers. But dense rank will hit all the integers. Similar thing here. So this dense rank is going to be partitioned by color. So for each color, it's going to start again with 1. This is the black color, which is first, and then we'll skip down. We'll see another color. I'll go to here to the end of multi. So the end of multi is 8, and then the beginning of NA is 1. So it's going to start 1, 2, 3, 4 again, and then also rank will start 1, 2, 3, 4. And then repeating what I said, dense rank will hit all the integers. Rank may skip integers. Okay, similar thing here, and I'm not going to show it, but we can do the partition by color. We can order by some other key, which is in descending order, and also you can do the keys here, which are multiple keys. All right, we want to do an entile partition. I'm actually going to skip to the second one here. Entile 7 over partition by color, order by product alternate key as product alternate key entile. So what's this going to do? We want to make 7 groups. We're going to make 7 groups within each color, and they're going to be done by product alternate key. So here where I have color black, there will be 7 groups inside of black. So 1, 2, 3, 4, 5, 6, 7. And they're going to be evenly distributed, as best can be. It's going to be not completely calculated, because if you take just a group and you divide it into 7 piles, you're not necessarily going to get the same number in each group, but it's going to be approximately the same. And then blue, so it's going to start over again with blue on the entiles, and it's going to give me the blue rows divided into 7 groups, the multi into 7 groups, the NA into 7 groups, and further on. Now, what I just showed here with the 7 grouping thing, now I want you to think about 2 things. Number 1, how would you do that in Excel? How would you do just what I said in Excel? Because it would be difficult. Secondly, if you did this, and now this was my key, and let's say this was some sort of data science activity, what I now have is, if I took all those ones and combined them together, I'm now going to have proportionally the same number of blacks will be distributed across the 7 groups, and then the same percentage of blue color will be distributed across 7 groups, and yellow will be distributed across 7 groups, and red, whatever the colors are. So even if there's a long list of blacks and not too many blues, what you're going to be assured of, I just made 7 groups that have probably representation from all the color groups. They might not have, because we might have some colors that have less than 7, and in that case it's just going to go to what it can go to. Like if it only can go to 5, it'll go to 5. But if it had 7 or more, then you're going to have that many in each group. The grouping type of thing I'm talking about is something that may come up in data science. What I just said is not what you're going to get from the advanced algorithms. They're not going to do this type of feature creation. And what also, because it's not a linear combination, this is a grouping thing. And the second thing is it's very difficult to do what I said in Excel. Right, I'm going to go back to the slide deck to talk about our next topic on aggregates. Okay, so again, what is a window? It's a set of rows, so the order by it's going to put the sets together, partition by it's going to divide them up. These are the functions. Now here's the order. This is the order of the SQL statement, how it's processed. And what I said earlier is that we happen to see a lot of them in order, a certain order that I expected, but if I have multiple statements, they may not be in that order, so you may have to use this order by statement as the last thing to get it in the correct order. Let's look at some aggregate functions. I'm going to go here because this is easier. 9. All right, max over is going to give me the maximum over the whole thing. Over with nothing in there, it's going to give me the max over the whole thing. So if I have this variable safety stock level and I'm going for the max safety, it's going to give me the maximum of the entire column as that number. That's the max. Then here, now I'm going to do maximum over order by color and also maximum over partition by color. So what's that going to do? A little more complicated, right? So here's color, and here's the safety stock level. Here's the max safety order by color. Here's the max safety order partition by color. So the max order by color really is the same as just doing over the whole thing, because it doesn't really matter what order the color is in, the maximum number is still going to be the same number, which is 1,000. Where it's going to make a difference is partition by color. And partition by color meaning that this is the maximum right there, 1,000 for black. But if I go to a different color, like multi, the maximum for multi is 4. However, the maximum for those rows here, if you just do order by color, it's still going to be 1,000. And the reason is because that's for the entire group. It doesn't divide it up. It's going to use the whole thing. The only time it's going to do a partition is when I say partition by. So my point here is you're probably wanting to use partition by if you're using these aggregate functions. And that's what I did here. So here now we let the gates loose and we want to use all our window function aggregate. We can get the max, min, average, sum, count, standard deviation P, variance, and variance P. And look what I'm doing. I get all of these by color. So now this is something that you might find very useful for data science. Again, how would you do this in Excel? All right, how would you do it? You would have to do it for selecting your range for a particular group, and then you'd have to figure out, what is the max, the min, the sum, the standard deviation. I do it here, and I get it for all the groups. And if I go to one of the boundaries here, let me go between gray and some of these other numbers. Now, of course, standard deviation, this gray, there's only one observation. Standard deviation is not defined. It comes out as null. And we can see the count, the sum, the average, the min, and the max. And it's done by group, which is then what group? Color. Color is the group that I said. Color is what it's going to do. And, all right, so here's some extra sauce. Not only can I do those combinations, but now I can combine it as an equation. This says, give me the max over that particular color and subtract the min over that particular color, and that's going to be the difference. Or give me the average, or give me the sum divided by the count, or give me the max minus the min. Now, what I'm showing you right here, these features are new, and they would be very difficult to get any of the advanced data science engines to do that for you. You need to do this yourself, and you need to do it yourself and introduce this into your data science. Don't expect some advanced algorithm to come up with this type of combination as one of your features. I mean, you're going to have to do these calculations. If you think that these differences or sums or averages make a difference on your data science investigation, then you need to state them. And this will require some thinking through what you want on your features. Going to 10. All right, one thing I want to say here, this first query will not work. And it will not work. See, I'm doing a group by, but as I said earlier, group by is not required. If I try to execute that command, let's see, first of all, we have to execute this command. All right. Then I'm going to try to execute this command here, similar to one I did previously, and it's going to say it's not contained in an aggregate or group by function. I'm going to select it a little differently. You see here I'm dropping off the group by, but I'm doing the rest of it, and I do execute. That works. So that's going to do the maximum, and then you're going to be able to see that by color. So my point here is that you do not use the group by when you're doing this partition. All right, advanced query here. So now we're going to do from the dim product. First we are going to do group by. But let me just execute it first, then we'll talk about it. Execute it. What it's going to do is take each color, it's going to count them, and then it's going to do the count of the counts. So there's 133 black, 28 blue, 1 gray, 18 multi, and then the count of the counts means that if I look here on the output, there's 10 rows. That's where the 10 comes from. It's the number of rows, the count of the count. All right, let's try this one. Sum of the sum. What's that going to do? What's that going to do? It's going to sum all the black values together, and it's going to do it by color, and then the sum of the sum is going to sum the whole thing together. And notice here I put over parentheses, meaning the whole thing. I didn't put a partition by. Could I put a partition by? That might be some extra homework. All right. Here's the sum, and here's the count of the sums. The count, again, is 10 because there's only 10 rows. This is the average of the sums. Whoops, went too fast. This one is the sum and then the rank of the sums. So look at what it's doing here. It's going to do the sum of that, and it's going to do order by, and notice that I put the function inside the order by. So the first rank is going to be 1. That's going to be the sum of 4, and then 16, and then it happens to come out in increasing order. Again, don't count that it's going to come in this order. If you want it in a particular order, you need to do an order by. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to rank, and then it's going to do the sum. So this is an example here. This one is going to have to pick an order because I have 2 functions. So you'll see here, the rank of the average goes 1, 1, 1, and then it goes 9. You say, well, wait a minute, why does 9 come next? Well, the reason is because it happened to order it by these rank of sums, which this one is in a nice order, and then the rank of average it's not in a nice order because it had to pick an order, and it happened to pick rank of sums as the order. So this shows how to put the aggregate function into the overstatement, And then I can do 3 of them. So I did 2, now I'm going to do 3. There we go, we got 3. We put the rank of the sums, the rank of the counts, and the rank of the average. And that's what that one does. Question, and this is what I asked when I have the in-person audience, how to get rid of the NA? You do where clause. What happens to the variance of gray? It's undefined. And I have a common table expression, and I'm going to do the rank inside the first one, and then I'm going to do an overall rank. So let me execute it. And what it's going to do is this overall rank is going to be ordered by the sum of the ranks. So this gray was ranked 1, 1, 1. It's going to be 1. And then what it's going to try to do is it's going to use the individual ranks to come up with an overall rank. That's what that one does. Kind of tricky. Okay, let's go. We have only a few minutes left. We got to go through here, and now we got to talk about rows. So there's rows and range. Rows covers, it's a physical operator, it's faster, and range is a logical operator, it's slower. Here's the difference. Well, first of all, let's talk about what is a default frame. The default frame, if you don't say what the frame is, it's going to be the first row of a partition to the current row. First row of the partition to the current row. You say, well, I don't know what that means. Well, I put this in the slide deck so that you remember that this is the rule, and now we're going to talk about this. So these are the rows, and I've put them in order here. You're not going to see it on the screen, so this is actually 90 degrees of what you would see on an Excel table or SQL Server table. If you have the current row of 7, and I go 1 following, then that means 8. If I say 4 preceding, that means 3 through 6. Unbounded following means to the end. 1 preceding means 6 by itself. 2 following means 8 and 9. And unbounded preceding means all the way back to the beginning. All right, so this is the chart. I know you say, well, I don't know what that means. Well, we'll see some examples, but this is the chart that goes with the demo that I'm about to do. Range is different. Range is logical. So current row is 50. If I do unbounded following, it means start at the beginning of the 50s and go to the end, which is going to be the 5th observation. If I say unbounded preceding, it's going to start with the logical 8, and it's going to go back all the way to the beginning. And notice these overlap, and they overlap because 50 is a big group. So what you want to do is, in the range case, what we want to take the entire group all the way to the end, or the entire group all the way to the beginning. Again, what I'm showing right now, you're not going to see advanced data science engines coming up with features like this. All right, it's just not going to happen. You're going to have to do it yourself. Framing. Okay, I have to Move that. All right, so first of all, it's going to determine the maximum safety stock level over the entire set. And that's this first one here, and it's going to be 1,000. And the second one here, this is going to be ordered by color. Rows are between unbounded preceding and unbounded following. And because you said between unbounded preceding and unbounded following, it really means the same thing. Okay, so it's going to have the same number for both of those because those are equivalent statements. Let's do one where it's different. If I say order by this, rows between unbounded preceding and current row, then it's going to take that maximum safety number and it's going to be from the beginning till now, what is the maximum safety stock level? So this is going to be 500, 500, 500, and then this one's 1,000 here with this fourth row, so the number is now 1,000. And then the number's still 1,000 because that's still the maximum that it's hit so far. This one happens to be 4, but it would still go to 1,000. Then we can do things like current row and unbounded following. So that's going to be from the current row till the end of the data set, what is the highest number? And then the rows between current row and unbounded following. So this is going to be partitioned by color. So that means that in the partition case, it will be different, and the numbering is going to start over again with each color. In the case I'm looking at here, between current row and unbounded following, this might as well be the entire data set because that's what it's going to do. The entire data set, it's going to look at the whole thing. The partition byte will make a difference because right here 4 is the maximum for black, but it's going to change depending on where you are because what will happen is this 4 until it gets to 500, and then it's going to go to 500. I know this is kind of tricky to think about. So this is why I always say do this with a sample. And then 1,000, and then it's going to start over again with blue. Blue's going to be 100 here because it's going to start with a new group, and then it will be increasing, and it'll increase by partition. Now we're getting into tricky stuff. Now this is going to do the max, the min, the average, and this is going to be partitioned by color, rows between unbounded preceding and current row, which means from the beginning of the data set to where you are, give me the maximum number. These types of functions are useful if you had a time series data set. If you sorted it by here and sorted it using the order by date, you put some sort of date in here, then you would have the maximum number between the beginning of time to the current row, which is wherever you are. And remember, this is using rows, and rows is a physical operator. So it's going to be the physical row. It's not going to be the logical group. So if you have someone on the same day, it wouldn't be the same group, but it's going to be depending on which number it hits. But again, how would you do that in Excel? I don't know. I think that it would be very difficult to do what I just said here in Excel, but you see how it breaks up. And then maximum also, because I'm partitioning by color, it's going to start again with the next color. And that's the type of result you would expect. Okay, I'm not going to study it in detail, but I'm just going to tell you that's possible. And again, this one here, this is very similar here where I said we can do equations. Again, this type of equation, I would not expect an advanced data science engine to come up with this equation where you're doing a max minus a min. And by the way, these two over clauses could be different. I made them the same here, but they don't need to be the same. They could be different. So I'm just telling you some of the advanced things that you could do with your maxes and mins. Okay, 12. Range. Now, to do range, I had to make a fake table, which is this table here. And you notice some of the numbers are the same, and it follows exactly what's on the slides. So if I do select sales, so this is only a few observations in this particular table. And you see one, what's going to do here, it's going to count, and it's going to do the range between. So what it's going to do, 1, 2, 3, 4, 8. 8 meaning all these numbers are 8 because they're logically together. and then 9 will be the last number on that list. So what we're saying here is it's going to do something different for these 50s. This is going to be sales, count sales over order by sales, and then range between current row and unbounded following. So that's going to be the count done that way. And then let's see what happens when we do our full statistics across this data set. So what will happen here, first of all, the standard deviation and variance don't mean anything for this first one because there's only one observation. But what will happen is all these groups, all these rows here that have 50 on them will have identical statistics. And the reason is because it's doing it logically. All the 50s will be considered together, and the other ones will have different numbers. That's the idea. They're all together. So that's if you want your numbers to be all together, you want to use range. Range is for when you want to use them all together. Okay, the last one's going to be analytic functions, and I see we're coming to the end of our time. We may go a few minutes over. Again, what is order by? What is partition by? What are these functions? And we have a demo for analytic. I'm just going to go straight to the demo, execute. Now lag and lead are very cool. Lag without a number defaults to 1. So what it's going to do here, we're going to order by color and safety stock level. Ooh, you know what? I just changed the order. Okay, color and safety stock level. Lag means give me the previous number. Lead means give me the next number as far as safety stock. And right now it's because there's no number here stated, but you can put a number parameter. If I hold over the query, it's going to say I can put, first of all, it's going to say that that's a small int number, but I can put a number in here and it will go 2 or 3 or any number forward. But right now it's just set to 1. So it's like give me the next number, give me the previous number. Lag meaning behind, lead meaning in front. Okay, first value and last value is going to be the first value over a group, and that group here is color and safety stock level. And last value means the last value in the partition, which is what I said, unbounded proceeding to the current row. And that's why this one's 4, because that number's 4, but this one will jump to 100 because that's the current row there, 100. It's kind of a quirky thing. You have to think about what last value will do. I would recommend looking at the help screen or even trying some sample queries if you want to learn more about what last and first value do. Okay, percent rank is going to give us percent rank. Notice how I'm doing it. I'm ordering it by color. I don't have any partitions on here. I could put partitions in here. I don't have any, but what it's going to do is it's going to start with 0 for the percent rank. Cumulative distribution is going to do it as a group. So the way I like to think about it is percent rank will start at 0 and then it will go all the way to the end, and the last number here is 95th percentile. We had some ties. Compare it to cumulative distribution. This one starts with 0.05 because this first group represents 0.05% of the entire distribution, and then it will end with the number 1. So that's the way I like to think about them as being different. Percent rank starts at 0, cumulative distribution ends at 1, and that's the difference between the two of them, but they do something very similar. And then there's 2 functions here, percent cont, percent disk, and these are when you want to ask for which, if you want the 50th percentile number using this criteria, then it will give it to you. And the difference is percent cont will be interpolated, but percent disk will be exact, meaning that it will be found in the data set. So I'm going to show that here, percent cont and disk. And this particular one, let's find out one where they're different. So what it means here in this particular case, it's calculating 2 percentages. and again, you'll have to think about this later, is that the disk will be in the data set, which came from standard cost, but the percent count is not there. It's an interpolated value. It's an interpolated value. And I think probably what it did is it interpolated between the two 19s and the 20. I think if you take these three and divide them by 3, but I haven't done it. So don't quote me. Don't know if that's going to work. All right, so I'm coming to the last few slides as we end up here. There are some caveats, but if window functions cannot do the job, something else can. You may want to try common table expressions or the cross supply. So if you can't get what you want with the windowing functions, and in fact, you did see where I did use some common table expressions, but these two functions also will do similar type things. I had mentioned that some of the functions were non-deterministic, meaning that there's not one unique way to do the job. And the reason there might not be a unique way is because some of those order by statements were not done on unique keys. It doesn't require a unique key in the order by, so you might not get a unique value. And that is true for all the ones here that are in yellow. They may not be the same if you do it again a different time. And there's a place for you to study it. 2 books. The first one here is on SQL Server query performance tuning. This one I recommend so that you understand how to interpret the performance of your functions. And then also I want to recommend this book, which is Expert T SQL Window Functions in SQL Server. And I think it also has additional examples that you could get. And these are not the only things. There's a lot of free information on the web. But that's the end of my presentation, so I'll transition back to Luis.
Great, thank you, Mark. That was a really great presentation. And I'd like to thank everybody who attended to the meeting today. And as a reminder, we will be sending out an email with information once the video is posted to our YouTube channel, as well as with the information of the slide share where the slides will be posted. Again, thanks everybody, and we look forward to the next meeting. Thank you, Mark.
Sure.